Hello. In this video, we're going to go ahead and look at the definition of a polynomial function. So a polynomial function has the form of p of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 all the way down to a sub 1 x plus a naught. Now, the n is a non-negative integer and the coefficients are real numbers. Now, these out here are coefficients. The exponents are integers, specifically non-negative integers. Okay, so this isn't really different from what you've seen in the past. All right, so let's look at an example of a polynomial function. We've actually seen several in the past already. So if we look at this, we have, let's just say, x squared minus 2x plus 1. This is a polynomial function. We could also have x to the 5th plus 3x minus 15. That's a polynomial function. 42. 42 is a polynomial function because it's just this constant term of the polynomial function. That's it. That's perfectly fine though. And something like this is also one. 2x plus 5. 2x plus 5 is a line, but a line is a polynomial. So a lot of equations and functions that you've seen in the past have been polynomials. It's just that polynomial is a more generic term for those types of functions because it includes even more than what we have been looking at in the past. Now, polynomial functions are smooth and continuous. Now, smooth means that there are no sharp edges and that there are no jumps in the graph or any holes in the graph or anything like that. The smooth means that there are no sharp edges or anything like that, or no jumps in the graph. Also, continuous means that there are no jumps in the graph, and you can basically draw it by never picking up your pencil. Now, the domain is always all real numbers negative infinity to infinity. And the reason why, again, we're missing the even indexed radicals or the rationals. Okay, so what we have here is we have the graph of a polynomial function. And the great thing about this polynomial function is that it illustrates a lot about what we've just been talking about. Now, I'm going to go ahead and circle some things. I'm going to circle these. Right there, and right there, and right there. All of those are very important aspects of this polynomial function. What this does is it basically tells us where the function is equal to 0. And this is important. We've been trying to solve where functions are equal to 0 many times in the past. And so looking at this, we actually have these values. Now, looking at this, these are called zeros. So I'm going to say r comma 0 is a 0. So all of these, if you were to write these down in coordinate form, these are the zeros of the function. Now, r is a 0. I shouldn't say the coordinate. So r is a 0, meaning the coordinate r comma 0. Sorry, that's better there. This also has another name called roots. Because we kind of think of this x-axis as the ground, and anything below that is where it's going to start having roots, or in other words, it can touch the x-axis like it does here. Those are all roots. So root, a 0, or even an x-intercept. Why did I say is a 0? That's weird. Let's just say x-intercept. There we go. That's better. So R0 is an x-intercept, R is a 0, and R is a root. All of those mean the exact same thing. Now, notice there's actually even more going on here than what you may think. There's also a Y-intercept, and the Y-intercept is somewhere in there. I don't really care where it is right now, just know that it's in there somewhere. But we also have a lot more going on. We have some weirdness happening at these roots. Some of these are crossing, some of these are bouncing, and some of these are going straight across. And even more important, or not more important, but even more interesting thoughts is that notice that this is going down in both directions. That means that this doesn't have a range of negative infinity to infinity. This range is limited. And that happens for a reason. All right. Well, I'm going to go ahead and end the video here. We will actually come back to this particular graph again, and we'll talk more about it a little bit later. Alrighty, I'm going to go ahead and end it here, and I will see you in the next video. Have fun.